Now in this video, we are going to take up one more problem on the projections of laminas. How to solve this problem, how to analyze this problem and solve it by using the sketchbook. A regular hexagonal lamina of sides 25 mm is lying in such a way that one of its corners on HP, while the corner opposite to the corner on which it rests on VB. If the lamina means 60 degrees to HP, draw the projections of the lamina. So how to solve this problem? So first we will go for the initial position. How to consider the initial position? Since he says one of its corners on HP, so since the corner is resting on HP, obviously you have to start the problem from the top view. So here you can see when you are look from the top view, you will going to get a hexagon such that the corner is at end to end. So we have, when you look from the top view, all the sides are visible. So A to B, B to C, C to D, D to E, E to F and F to E. F to A is the hexagon which will going to be in corner position. And now when you, what is the position of this hexagonal lamina with respect to both HP and VB? The lamina is parallel to HP and perpendicular to VB. Since the lamina is parallel to HP, so in HP you are getting the true line. Where is HP? HP is the below XY line, and also when you look from the top view, you can see all the sides are visible, wherein having the true length of 25 mm. Then when you look from the front view, since it is perpendicular to VP, so you are getting a line, the front view. As we look from the front view, A, B, C, D is near to the observer, so A dash, B dash, C dash, D dash is visible. E and F is away from the observer, therefore E dash and F dash is invisible, it is in bracket. So E is coinciding with C and F is coinciding with B. So you have this as the initial position. Then how to write this in the sketchbook? So first we are going to draw the XY line and you mark VP and HP. So you consider in the horizontal plane, you draw one horizontal line of any length and you take one position on that horizontal line, and by using the compass you measure a radius of 25 with taking any one center on the horizontal line, and you draw a radius of a circle of 25 mm such that this horizontal line is cut at the 2 points and you mark them as A and D on that horizontal line. Then with A center, taking the radius of 25, cut an arc here and also on this side. Similarly with D as center, take the same radius of 25, cut an arc on the circumference of the circle, which is E and C here. And then you mark A, B, C, D, E, F. Then join A to B, B to C, C to D, D to E, E to F and F to A with a dot line. So this is how you will be able to write the hexagon, that is polygon inscribed in circle. Then you draw a vertical projector from A and D to the XY line. Then draw a vertical projector from BF and CE to the XY line. So then as you look from the front view, A, B, C, D is visible. So you mark those 4 points, A dash, B dash, C dash, D dash. Whereas E and F are invisible and it is coinciding with C and B. Therefore, you will have above C dash, you are going to have E dash in bracket. Similarly, above B dash, you are going to have F dashes in bracket. So this is how you will be able to analyze this in 3D, the first position in 3D, and also how I will be able to write in the sketchbook the front view and top view of the first initial position. Then he says it is resting on one of its corners. What I am doing is, since this side is also, this end is also a corner and this side end is also a corner, so therefore I am rotating about D dash. Even you can rotate by using A dash also, because it's the corner position. So you take, then what I need to do, you rotate this hexagonal surface such that till the surface becomes inclined at an angle of 60 degrees to HP. Then as you look from the front view, you will going to get a vertical line here. As you look from the front view, BCD is invisible, BC becomes visible, and F and E will going to become invisible. Therefore, you can see that F dash and D dash is invisible, B dash, C dash is visible, then D dash and A dash is also visible. So you have A dash and B dash without bracket. So such that the surface is inclined at 60 degrees to HP. So what is the position of the surface with respect to both HP and VP is the surface is inclined to HP, where you can see the inclination. The inclination you can see in the front view. So when you look from the front view, the image will going to fall on the vertical plane. So since it is perpendicular to the vertical plane, therefore you are getting a line here. So as you look from the top view, from A and B, you draw a vertical projector to the HP. Similarly, from C and E also you do the same thing. Similarly, from F also you draw a vertical projector onto the horizontal plane. So then for that you will going to write the top view. So what is the position of the top view and front view? Here the surface is inclined at 60 degrees to HP, but that surface is perpendicular to VP. So that is the reason why you are getting a line in the front view. So as you look from the top view, you will going to get the image as A, B, C, D, E, F and A. So this is how you will be able to analyze the problem in 3 dimensions in the second position. So in the second position, the surface is inclined to HP and it is perpendicular to VP. Now how to continue with this in the sketchbook. So you extend this XY line and you take any convenient distance between D dash and this D dash to this small D dash. You mark a point on the XY line at any convenient distance and you mark that point as D dash in the front view. So by using the protractor with reference to the XY line with D dash as center, measure in the clockwise direction. So then you mark a point on that 60 degree line. Then by using from D dash you draw a point which was been given on the 60 degree line. You draw that, you draw from D dash, you draw an inclined line at an angle of 60 degrees. Then you measure the distance from D dash to A dash by using the compass. Then with D dash as center, cut an arc on that 60 degree line. You mark that point as A dash. Similarly, draw by using the D dash to B dash with D dash as center, cut an arc on this. Since then you measure the distance from D dash to C dash with D dash as center, cut an arc on this. Then you mark A dash, B dash, C dash, D dash, E dash in bracket, F dash in bracket. So this is how you will be able to rewrite the second position front view. Then to this I need to write the top view. Draw a vertical projector from A dash and D dash to the top view. Draw a horizontal projector from A and D. Both these two lines will going to intersect at this point and also at this point. You mark them as A and D. Then draw a vertical projector from B dash and F dash to the top view. Similarly from C dash, E dash is also to the top view. Then draw a horizontal projector from both B and C to these two lines. Similarly from E and F also you draw a horizontal projector such that it will go to end at the E, that is C's end projector, and also with E. Now once you get this, both from A, B, C, you mark them A, B, C, D, E, F and A. Then join A to B, B to C, C to D, D to E, E to F and F to A with a dot line. So now you got the second position top view. Then how it will going to be look here is here in the second position top view, none of the lines are parallel to HP. Therefore, the entire figure will going to become the apparent length. Now, the corner opposite the corner rests on VP. So what does it mean? Since the corner resting on HP is D, this corner opposite to the corner is A dash. It is on VP. Then you rotate this in clockwise direction such that you can keep that A on the vertical projector. Then as you look from the top view, here draw a vertical projector from B and C to the HP. D is already there, A is on VP. So then draw a vertical projector from E and F to the horizontal plane. Then join ABCD. This is the image ABCDEF is the image for this three-dimensional sketch. And as you look from the front view, this B is being projected here to VP, F is projected to VP as F dash, C is projected to C dash, and E is projected to E dash, and of course D is there in the XY line. So then you will going to get, as you look from the front view, you can see the horizontal, that is hexagonal surface, such that it is perpendicular to HP, but it is not perpendicular to HP because BC is inclined to HP. So but what happens, B and B dash and C dash appears to be perpendicular. Similarly, BC is also appears to be perpendicular to VP. So this is how you will be able to analyze this problem by using the three dimension. So how to write the third position top view? The corner opposite to the corner is rests on AP, which is the corner opposite to the corner which rests on HP, that is D dash. The corner opposite to that is A dash. So A dash should be on VP. So what I need to do is I need to rewrite the second position top view such that A will going to lie on the XY line in the top view. So to do that, you take any convenient point on this XY line with certain distance from BD dash and you mark that point as A. Then draw a vertical projector from A to the top view. Then by using the compass, you measure the distance from A to D with A as center, cut an arc on that vertical projector. Now you mark that point as D. Then you measure the distance from A to this point, which is the same as from D to this point. Then transfer it from A onto this line and then from D onto this point, and draw from both these 2 points. You draw a horizontal line. Then you measure the distance from this point to B, which is same as this point to C, which is same as this point to F and this point to E. Similarly, with this as center, cut it on this side. You measure the distance from this point to here with this as center, cut an arc on this side. And then similarly from D, you measure the distance up to this point. From D, you cut it on this and draw 2 horizontal projectors. Then you measure the distance from this point to B, which is same as this point to C, which is same as C to E, and then this point to F. So from this point, you cut an arc on this side and also on this side. Similarly, from this point, you cut an arc on this horizontal line and also to this horizontal line. Then you mark these points A, B, C, D, E and F. Then join A to B, B to C, C to D, D to E, E to F and F to A with a dot line. So I need to write the front view. Draw a vertical projector from A and D to the front view. Draw a horizontal projector from A dash and draw a horizontal projector from this. So both these 2 lines will going to intersect at this point. You mark that point as A dash and similarly you mark this point as C dash. And then you draw a vertical projector from B and C to the front view. Similarly from C, E and F to the front view. Then draw a horizontal projector from B dash and F dash and also from C dash and E dash. These 4 points will going to intersect at this point and this point, which is B dash and C dash. You mark them as B dash and C dash, and similarly from E dash to F dash. Similarly, you mark from A dash to F dash. Of course, D dash is already mentioned. So then join between A dash to B dash to C dash, C dash to D dash to E dash to F dash, and F dash to A dash. So this is how you will be able to write the hexagon by using the sketchbook. And how do I know that my problem is right? you can see that one of the corners is resting on HP, which is D dash, that is this point. This corner opposite the corner, that is A dash, should be on VP. So A is on VP. So that means you are rotating the second position, front view, top view, to in clockwise direction and keep it. So how do I know that my problem is right? So A corner is on HP, the corner opposite to this corner, which is A, is on VP, and then this surface is inclined to HP at 60 degrees, and then you have a hexagonal lamina of 25 mm sides. Since all the data which was given in the problem is considered in solving this solution, and hence my problem is right. Thank you.